Hello students, I am Narendra Ade from RCRT Chandrapur. In the previous video, we look into projections of the plane which is inclined to the one plane and perpendicular to the other plane. In this video, we will see how to draw the projections of a plane which is inclined to both horizontal plane and the vertical plane. The plane which is inclined to both horizontal plane and the vertical plane, it is called the oblique plane. Projections of the oblique plane. The plane which is inclined to both horizontal plane and the vertical plane is called the oblique plane. Whenever plane is inclined to both horizontal plane and the vertical plane, you have to solve the problem, you have to draw the projection in 3 stages. Just now in the previous videos, you have seen that one when plane is parallel to the one and the perpendicular to the other plane, you have to solve the problem in the one stage. Means it is in the simple position, then you have to solve the problem in the one stage. When plane is inclined to one of the reference plane and perpendicular to the other plane, you have to draw the projection in 2 stages. And when plane inclined to both horizontal plane and the vertical plane, you have to solve the problem, you have to draw the projection in 3 stages. And that you have to remember for the given question in how many stages to draw the projections. That depend upon the position of the plane. When plane is in a simple position, solve in one stage. Plane inclined to the one of the plane, perpendicular to the other plane, draw in the 2 stages. And when plane is inclined to the both the plane, then solve the problem in 3 stages. And in that one, you have to take inclination of the surface in the second stage of that is a plane, and any other inclination, maybe the edge inclination, maybe the side inclination. In case of the circular plane, diameter inclination, or in the polygonal plane, some other diagonal inclination, that you can take in the third stage of the problem. But in all the problems of projections of the plane, surface inclination you have to take in the second stage of the problem, and the other inclination, maybe the side, maybe the edge, maybe the diameter, maybe the diagonal, all you have to take in the third stage of the problem. So here, see that one, I will take a question directly. Draw the projection of regular hexagon of 25 millimeter side, having one of its side in the horizontal plane inclined at 60 degrees to the vertical plane, and its surface making an angle of 45 degrees with a horizontal plane. So from the given question, see the surface inclination. Here surface making 45 degrees with a horizontal plane, and additionally one of the side making 60 degrees to the vertical plane. So meaning that plane is inclined to both horizontal plane and the vertical plane. Therefore, you have to solve the problem in 3 stages. You have to solve the problem in 3 stages. Then you take the surface in all the problems of projections of the plane, you have to take the surface inclination in the second stage, and from that one you have to decide the first stage. Means you have to decide where to draw the true shape of that plane. Here plane is inclined 45 degrees with a horizontal plane. Plane is inclined 45 degrees with a horizontal plane. Therefore, that you have to take in the second stage, and the plane inclined to the horizontal plane, then its inclination seen in that is the front view. Inclination is seen in that is the front view. Therefore, in the second stage, in the front view, you have to take a 45 degrees. If the plane is 45 degrees, any angle inclined to the horizontal plane, in the first stage, you have to take parallel to the horizontal plane. As your side is in a horizontal plane, therefore, instead of taking the plane parallel to the horizontal plane, you take the plane in a horizontal plane. That is the assumption. That is the assumption. You can take here. Here the side is given in a horizontal plane. Therefore, you have to take the plane in a horizontal plane. As plane is in a horizontal plane and perpendicular to the vertical plane, the true shape of the plane in the first is in the top view. So for this and a problem, true shape of the plane is coming in the top view. Okay, now here a hexagonal plane is given, the regular hexagon of 25 millimeter side. Now the question is how to draw the hexagon. How to draw the hexagon means what is the position of that in the hexagon. I means the two sides remain vertical, in the true shape where two sides remain that is in a horizontal. That also you have to decide. and that depend upon the side of the plane. Here suppose the corner of the plane given in the question. The questions of the projections of the plane, they are in a sideways problem and the corner based problem. Here side is given in the question. Therefore, while drawing the true shape, whenever side is given, you have to draw that in a polygon, maybe the sphere, maybe the triangle, pentagon, hexagon, yeah, any sort of the polygon, maybe the regular, irregular. You have to take that side perpendicular to the xy. Here side is given, therefore take that in a side perpendicular to the xy in the top view and draw there the regular hexagon. Draw there the regular hexagon. So this is the true shape of the plane, in that is the top view. That is the starting of that is a problem. Starting of that is a problem. Then project it up to the xy line. On a xy line, here we will get that is in a line that is the front view of that is the plane. Front view of the plane. Then in the second stage of that is in a problem, take this is the one of the side, and which side, a and the AF. Here a dash and f dash, that represent the side AF. Taking this as a side AF on xy in the second stage, draw the line making that is in a 45 degrees, and along the 45 degrees take the length of the surface. Here a dash c dash, from the first figure that length will remain the same figure you have to draw here, but at a given angle. Length will remain the same, figure will remain the same. Here it is in the xy in a horizontal position, here it is in a inclined position as per the given inclination. You make the plane inclined to the horizontal plane by an angle of 45 degrees. Then in the same way, draw the projectors perpendicular to the xy. Then from the previous top view, you draw the lines parallel to the xy. Mark the point of intersections. Mark the points of intersection. Here we will get the top view. Here we will get the top view. But this is the top view. This is the reduced hexagon when plane is inclined to horizontal plane and perpendicular to the vertical plane. Inclined to the horizontal plane and the perpendicular to the vertical plane. Suppose in the question plane is given 45 degrees to the horizontal plane and perpendicular to the vertical plane, then this is the solution of that is the problem. You have to solve the problem in the two stages only. This will be the solution. You have not to draw the third stage of the problem. When plane is given inclined to the one and perpendicular to the another plane, you have to solve the problem in the two stages. But in this case, that side is given inclined to the vertical plane. See that one, suppose the question is given resting on the one of the side, and that side is perpendicular to the VP and the plane making 45 degrees to the horizontal plane. All the data is satisfied here, means plane is ultimately inclined to the horizontal plane, perpendicular to the vertical plane. Here this is the solution of that is a problem. But here that side on which that plane is resting on a horizontal plane, that is inclined to the vertical plane. Here it is a perpendicular to the vertical plane. That side is given inclined to that is in a vertical plane. Therefore, in the third stage, now you draw the third stage. Now in the third stage, you first draw the line making an angle of 60 degrees. Given angle here given that is a 60 degrees. Line making that is a 60 degrees. Along the 60 degrees, take the same side, not any side, resting side. Which is the resting side? AF is the resting side in the second stage. Plane is resting on one of the side on the horizontal plane. On which side is the resting? It is resting on the AF. It is resting on the AF. Therefore, take A1, F1 on the XY, and you draw the same figure here. You draw the same figure, not the first figure. Don't draw the other regular hexagon. Don't draw the true shape of the plane. After drawing the second stage, to draw the third stage, you have to draw the same figure here, but at a given angle. You have to redraw that is in a same figure. You have to draw the second reduced figure in that is in a third stage. Don't draw that is in a figure of that is the first stage. Don't draw the true shape of the plane. This is not a regular hexagon. This figure is same of that is in a suppose the second that is in a suppose the stage. Line making that is in a 60 degrees. Along this one, take A1, F1 and draw this in a same figure as it is. This is the required top view, where one of the side of that is in a plane. One of the side of the plane inclined at an angle of 60 degrees. Inclined at an angle of the 60 degrees. Draw the projectors vertically, and from the previous front view, draw the lines parallel to the XY. Mark there the points of intersections. Connect that in a point in the correct sequence. In that is in a correct sequence. Now see that figure of 10, A1 dash, B1 dash, C1 dash, D1 dash, C1 dash and the F1 dash. This is the required front view, this figure A1, B1, C1, D1, this is the top view and this is the front view. These are the final projections. Final projections when plane is directly or indirectly, it is a inclined to horizontal plane, also inclined to the vertical plane, and inclined to the both the plane. So when plane is inclined to the both the plane, you have to solve the problem in the three stages, and the projections in the third stage, front view and the top view of the third stage, that is the that are the final projection. That is the solution of that is a problem. Now see that one, in the front view you are getting the reduced hexagon, as well as in the top view you are getting the reduced hexagon. Both are the reduced figure. You have to remember, when plane is inclined to the both the plane, front view and the top view both are reduced figure. Front view and the top view both are the reduced figure. You have seen from this an equation, when plane in a simple position in the first stage, when plane in a single position, plane is in a horizontal plane, and the plane in a horizontal plane, so in the top view you are getting the true shape of that is in a plane. When plane is inclined to the one of the plane, here plane is inclined to the horizontal plane, then you are in the top you are getting the reduced figure. And when plane is inclined to the both the figure, in the front view as well as in the top view, you are getting the both the figure. Figure reduces in a both direction, so front view and the top view both are the apparent shape, both are the reduced shape, not a true shape of the plane. This is not the front view is not the true shape, top view is not, that is the true shape. True shape, when plane is inclined to the both the plane, the true shape of the plane will not appear in the front view and the top view. True shape of the plane appear only the when plane is parallel to the one of the reference plane. That you have to remember. Whenever plane is parallel to the one of the plane and perpendicular to the another plane, then only then true shape of the plane appear in one of that is a view. When plane is inclined to the one plane and perpendicular to the another plane, you get a reduced figure in the one of the view. And when plane is inclined to both horizontal plane and that is in a vertical plane, then you get the reduced figure in the front view and the top view. Or even you can check that is in a data that is in a given, data that is in a given, see that one, that side is given, one of the side is given in a horizontal plane, here particular sides over the EF. That's why A1 dash F1 dash, it is on a XY line, means that side is in a horizontal plane, and in the top view A1 F1 making an angle of that is in a 60 degrees, means that side AF 60 degrees to the vertical plane and it is in a horizontal plane. In this way, we can draw the projections of that is in a plane when plane is inclined to both horizontal plane and the vertical plane. Take the next problem. A square ABCD of 50 mm side has its corner A in a horizontal plane, its diagonal AC inclined at 30 degrees to the horizontal plane, and the diagonal BD inclined at 45 degrees to the vertical plane, and parallel to the horizontal plane. Draw its projections. Draw its projections. So here also plane is inclined to the both horizontal plane and the vertical plane. That's why you have to solve the problem in the three stages. So here that it is a resting on the one of the corner. Here instead of that is a side resting, here corner resting. Problem is given, corner based problem is given here, that sphere plane resting on the corner A, and that specific corner is mentioned here, resting on the corner A. Okay. So here that one of the diagonal AC inclined at 30 degrees to the horizontal plane. That is the diagonal is along the surface, therefore if the diagonal is inclined, surface is inclined. Here plane is inclined 30 degrees to the horizontal plane, 30 degrees to the horizontal plane. So that you have to take in the second stage of that is a problem. And another diagonal BD inclined at 45 degrees to the vertical plane, that you have to take in the third stage of the problem. Here plane is inclined 30 degrees to the horizontal plane, take in the second stage of that is a problem. So in the first stage you take the plane in a horizontal plane, so that true shape of the plane in the top view, in the top view is a true shape. Now you have to draw the sphere, of 50 mm sides. But how to draw the sphere? Equally inclined, yeah, vertical, that will depend upon the what position is any given here. That sphere is resting on the corner, therefore instead of drawing the sphere in a vertical position, here you have to draw the sphere in a equally inclined position. Corner based sphere you have to draw here. resting on the corner. Then you have to draw the sphere in a equally inclined. Sides are equally inclined. After drawing the sphere in a equally inclined position, in the front view, on the left side as well as on the right side, there is a single point A dash. On the right side, that is a C dash. Single point, that is a representation of the corner. Representation of the corner. 2 points, that is a representation of the edge. 3 points, representation of the triangular face. 4 points, representation of the rectangular face. So these are the things in that is a supposed drawing that you have to remember. Resting on the corner, therefore there must be the single point. There must be the single point. So here after you have to draw the sphere in a equally inclined position. You are making 45 degrees, 45 degrees to that is an XY line. You draw the sphere. Then after drawing the sphere, that is the true shape of the plane. Project up to the XY. On the XY, you will get a front view. That is a line A dash suppose C dash. This is the length of the surface or the front view of that is in a plane, front view of the plane. Then in the second stage, it is a resting on the corner A. Therefore, resting on the corner A, take the A dash on the XY line, means it is a resting on the corner on a horizontal plane, and surface making a diagonal AC making 30 degrees to the horizontal plane. Here diagonal inclination means it is a surface inclination. Diagonal inclination means surface inclination, because in all the problem you have to take the surface inclination in the second stage of the problem. Instead of using the word suppose the surface, here diagonal word is any use, because the diagonal is along the surface. Therefore inclination of the diagonal means it is the inclination of that is a surface. You take the surface inclination in that you draw the line. After taking the A dash on the XY line, draw the line making an angle of 30 degrees. Along the 30 degrees, you take the length of the surface from the first figure. A dash, C dash you can mark here, means you have made the surface inclined to the horizontal plane. Then project vertically and horizontally, you will get the reduced figure. Now this reduced figure, it is not the sphere, it is not the true shape of the plane. That must be the rhombus. That must be the rhombus, because one of the diagonal, this vertical diagonal B1 D1, that will remain the same, and this horizontal diagonal, it get that is the reduced. Therefore diagonals are that is an unequal. Therefore this figure must be the rhombus. This figure must be the rhombus. Now, what is the remaining? The diagonal BD, it is inclined 45 degrees to the vertical plane. Here the diagonal BD is perpendicular to the vertical plane. Here diagonal BD is perpendicular to the vertical plane. We want 45 degrees to the vertical plane. Therefore, what you will do in the third stage, for draw the line, make 45 degrees, and along the 45 degrees take a B1 D1. Take a B1 D1. Make the diagonal for B1 D1 45 degrees to the vertical plane, and draw the same figure. By the geometry, you draw the same figure. What you will do, one of the simple way, first draw the B1 D1 along the 45 degrees, take the midpoint and draw the perpendicular. If the diagonals of the rhombus, they are perpendicular by bisector, therefore take the midpoint of the B1 D1 and draw the perpendicular. Along the perpendicular, take the length of that is from the center to the A1 in the upward direction, center to the C1 in a downward direction. Dark it. This is the final, that is the top view, where the diagonal BD 45 degrees to the vertical plane after surface making 30 degrees to the horizontal plane. You have not to change the position of that is surface. The surface is already 30 degrees to the horizontal plane, and after that one diagonal making 45 degrees to the vertical plane. Then in a usual way, draw the projectors in the front view perpendicular to the XY, and from the previous front view, you draw the lines parallel to the XY line and mark the points of intersection and connect this in a points. So see that one in the front view. Now you are observe, it must be the parallelogram. It is the parallelogram. This parallelogram is the front view of the plane, and this rhombus A1 B1 C1 D1 is the top view of that is the plane. These are the final projections. These are the final projections. See that both are the reduced figure. These are not the sphere, they are smaller than that is in a sphere. As the plane is inclined to the both horizontal plane and the vertical plane, projections front view and the top view both must be the reduced figure. Both must be the reduced figure. In the front view, you are getting that is in a parallelogram. In the top view, you are getting that is a rhombus. Now you can check that is in a given data. That is in a sphere resting on the corner on the horizontal plane. So in the final front view, you can observe the A1 dash, that is the front view of the corner. It is coming on the XY line. This figure, front view figure, looking is a square plane resting on the one of the corners. Suppose A. The A dash is coming on the XY, it is an correct, and in the top view B1 D1, that is in a diagonal, making 45 degrees to the vertical plane. 45 degrees to the vertical plane. In this way, you can draw the projections of radiance of the plane which is inclined to the one plane and the perpendicular inclined to the both horizontal plane and the vertical plane. So when your plane is inclined to both horizontal plane and the vertical plane, you have to draw the projections in that in three stages. In the first stage, you have to draw projection in a simple position. In the second stage, you have to draw the projections taking the plane inclined to the one of the plane, and in the third stage, take the plane inclined to the other plane. So final projections, front view and the top view, both are the reduced figure.